Alright, so we want to look at this problem here where we're going to use the properties of exponents to simplify this expression. And so what we want to do is we want to get this expression in a form that will be easier for us to use. There are two ways to do this, and it doesn't affect the orders of operations here. Since we have the same bases here, we have an x base and an x base, and I have a multiplication, I can add the exponents. So I get x to the 7th to the negative 2 power. And now I have a base to a power to a power, so I multiply. That's x to the negative 14th. And I have a negative exponent, so that's like bringing that underneath the fraction bar. And this kind of uses all of my properties of exponents. So this one I use a same base, add exponents. For this rule I use to a power, multiply exponents. And then for a negative, b to a negative exponent is the same as 1 over b to the nth. And so these are the rules I used and the order I applied them. But I can also do it one other way. I can distribute this first. We can look at, and I'll do my other way of doing it, as this power can be applied to each one of these. So I have x to the negative 8th times x to the negative 6th. I'm using the power multiplication rule to each part in here. This is very useful if these have different bases, but these have the same base. So now I can add exponents. Right, negative 2 times 3 is negative 6. So I add exponents, it's negative 14. And I get to the same place. I prefer working my way inwards out for that, but this rule comes in nice here. Like if I were to have x to the 5th and y to the 4th, then I can use the multiplication rule on each part, x to the 10th, y to the 8th. And so that's when we tend to do that first, but it's nice to notice that this gives you the same thing.